Modulus is defined as the ratio of tensile strength to tensile strain. The tensile stress is the force per unit area, so force divided by area, and the strain is the increase in length parallel to the applied force. So it's going to be the change in length divided by the length. If we divide the area of elements of A equals y squared, you have one intermolecular bond and its force F to consider. So the definition gives you the equation y equals F divided by A divided by change of L divided by L. Now if you go ahead and you want to change out the some of the values for constants, like A equals y squared, and you go ahead and do that, and L can equal R, and you go ahead and you derive that, you're going to get d divided by dr times fr equals d divided by dr, and your constant n times a divided by r n plus 1 minus m b divided by r n plus 1, and that's going to equal negative n open parentheses n plus 1 close parentheses a divided by r to the n plus 2 power plus m times n plus 1 times b divided by r to the n plus 2 power. What you're going to want to do is you want to substitute r for RO and use the definition of y. Now if you go ahead and plug that in, then of course you have RO here where R was before, and you're going to go ahead and get m minus n after you plug those in, because it simplifies down, and NA divided by RO to the n plus 2 power. And after you go ahead and simplify that down further, you're going to get y equals df dr RO divided by y squared, and that equals m minus n times NA after you go ahead and distribute, and that's divided by RO to the n plus 1 times y squared, where a, n, and m are all the constants in the equations, and r0 or RO and y are the interatomic separations in the longitudinal and transverse directions. And that's how you derive Young's modulus.